Okay, I'm going to go through some of these homework questions just so that you know how to get started on them and you're not confused. First, we are not doing number 1, so you can just mark it out. This is on page 75 in your book. Okay, there is a digital version of this, but it may be easier to work them out in your book and then put your answers into the digital assignment. All right, so it says the line of best fit for this data is this equation. Now remember, this is how you get estimates and predictions. And then it says find the residual for each of the following coordinates. Okay, so the residual is your actual value minus the estimated value. So the best way that I would recommend solving this problem is to create a table just like we did in 6.2. Okay, now I don't remember what page that is, but you can look back and see what page 6.2 is, the one we did with the oranges. So I would suggest making a little table here, writing all your X values down, writing all your Y values down. Okay, so let's do A first. Our X value is 5 and our Y value is 8.8. Okay, so those are our actual values. Now, next we want to do the estimate. Okay, well, how do we do the estimate? Well, we know we have to use that equation. So we have y equals 1.1 x plus 3.4. Okay, so that estimate is going to be for our y value. We want to estimate the, well, it doesn't tell us what we're talking about, but it's for the y value. So we know that x is 5. So we're going to just take that and we're going to plug it into our equation. Okay, we're going to find the estimated value. So we'll do y equals 1.1 times 5 plus 3.4. Plug that all into your calculator and you get 8.9. All right, now that's just the estimated value. That's not what it asked for. It asked for the residual. Okay, so we know that in order to find the residual, we just said, is we're going to take these two values and we're going to subtract them. Okay, so once we do that, we're going to get 8.8 minus 8.9. We're going to get negative 0.1. And that is the final answer for A. Okay, same exact process for B. We're going to plug in our actual values, 2.5 and 5.95. Okay, so once again, we're going to use that formula. So this was for A. This is going to be for B. Y equals 1.1x plus 3.4. Okay, but this time our x value is not 5. What is it? It's 2.5. Okay, so we have an equation. We have a variable. We're going to plug it in. So y equals 1.1 times 2.5 plus 3.4. And we get 6.15. All right, but that's not all we have to do. Residual says we do the actual value minus the estimated value. We have to do 5.95 minus 6.15, and we get negative 0.2. The only difference in this problem than what we did in 6.2 is we watched the oranges increase at a steady rate. We had 3 oranges, 4 oranges, 5 oranges, and this is just randomly choosing different X and Y values, okay? No difference, but I highly recommend creating that table to answer C, D, E, and F. Now, there is no reason why you should miss A and B now that I have showed you, okay? Now, if you still have questions, you need to come and ask me. It says we have these 4 graphs of residuals, and it says, blah, 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 which of the following represents the plot of the residuals for a model that fits its data best? Okay, well, if we're choosing the one that fits its data best, that means that all of the actual values are extremely close to the estimated values, meaning that all of those data points are really close to your x-axis. Okay, so look through those 4 graphs and choose the one where all the residuals are closest to the x-axis, and you will get that correct. Next, you just have to use this graph, and it says a local car salesperson created a scatter plot to display the relationship between the price of the car, which is your Y, and the age of the car, which is our X value. And you can see it all in your graph. The car salesperson looks at the residuals for the car sales price. Okay, it says for the car that is 4 years old, does the salesperson sell above or below her average selling price? Okay, so remember, residuals tell you how close the estimated value is to the actual value. So let's look at the actual and estimated for 4 years. Okay, so I'm going to go to 4 years. Here's my actual. There's my estimated. Okay, so was the actual value above or below what they were planning on? Okay, so you just have to answer that and explain based on what you observed in the graph. Okay, then we're going to do the same for 12 years. There's 12. Okay, let me kind of go back. So the line's going to be right there. Okay, that's going to be our estimated value. This is going to be the actual value. So do they sell, was the price above or below what they estimated it to be? And then just explain. And then on this one, you're going to be given a table. It's right here. There's a lot of data in it, but it says use, I think it says in your book, use technology. So this is where you're going to use Desmos. Okay, you need to practice those steps. So that's what you're doing here. What is the equation for the line of best fit? This is where you do the little equation into the Desmos after you do it. And it says, what is the slope of the line of best fit? What does it mean? Okay, we did all of this in lesson 4. Go back to lesson 4 if you're confused. That's the change of Y over the change of X. How is your Y value increasing or decreasing? By how much? For every 1 X value. What does the line of best fit estimate for the gas when the outside temperature is 59 degrees? All right, so in this one, it wants you to use that line of best fit equation to estimate when the temperature is 59. So when X equals 59, use that equation that you came up with in A, plug that in, and then get your answer. It says, how does the actual gas usage compare to the estimated gas usage when the outside temperature is 59 degrees? Okay, so compare the actual value to the estimated value when X equals 59. But just look at that point on the graph. Are they close to each other? Are they far apart from each other? There's all the data that you're going to plug in. Again, make sure you take your time on it, plugging in all of those values so that you get all the accurate data. Okay, and that is it for your homework for lesson 6.